This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
In this video, we'll go over a few different factoring strategies and how to figure out which one to use. Let's jump into some examples. For our first example, we want to factor 4z squared plus 12z plus 5. Since this is a trinomial where the leading coefficient is not 1, we will want to split up our middle term, 12z, and then factor by grouping. But how do we split up our middle term? Well, we'll want to rewrite our quadratic as ax squared plus r1x plus r2x plus c, where r1 times r2 is equal to ac, and r1 plus r2 equals b. So first, we'll multiply a and c, which are 4 and 5 here, to get 20. Then we want to find the factor pair of 20 that adds to 12. Let's list some factor pairs of 20. We have 20 times 1, 2 times 10, and 4 times 5. And here are their sums. The pair that adds to 12 is 10 and 2, so we have our factor pair. We'll write 4z squared plus 12z plus 5 as 4z squared plus 2z plus 10z plus 5. Now we'll group our first two terms and our last two terms and pull out the greatest common factor out of each pair. For 4z squared and 2z, the greatest common factor is 2z, so we get 2z times 2z plus 1. For 10z plus 5, the greatest common factor is 5, so we get 5 times 2z plus 1. Since our expressions in parentheses match, we can factor that expression in front to get 2z plus 1 times 2z plus 5. Great! Let's check our work by expanding. When we use the distributive property or the FOIL method to expand our factors, we get 4z squared plus 2z plus 10z plus 5, or 4z squared plus 12z plus 5, which is what we started out with. So our answer is correct. Great! Let's look at another example. Here, we want to factor 12h to the fourth plus 6h cubed plus 32h squared plus 16h. First off, we can see that all of these terms have a common factor of 2h, so let's start by pulling that out. That gives us 2h times 6h cubed plus 3h squared plus 16h plus 8. Now we can just focus on factoring further for what's inside the parentheses, which will make things simpler. Since we have 4 terms, we'll want to factor by grouping. We'll group our first two terms and our last two terms and pull the GCF out of each pair. The greatest common factor of 6h cubed plus 3h squared is 3h squared, so we get 3h squared times 2h plus 1 for the first group. The greatest common factor of 16h plus 8 is 8. So we get 8 times 2h plus 1 for the second group. Perfect! The parentheses in each group match, which is what we want. Now we can factor out 2h plus 1 to get 2h times 2h plus 1 times 3h squared plus 8. None of the expressions in parentheses can be simplified any further, so our final answer is 2h times 2h plus 1 times 3h squared plus 8. Let's check our work by expanding the factors. After multiplying, we get the original expression, so our factors are correct. Great! Let's do one more. This example is a little different because there are two variables, m and n, in the expression. But notice that we still have 4 terms, so we'll try factoring by grouping again. In these first two terms, the greatest common factor is 2m squared, so we end up with 2m squared times n minus 1 for our first group. In the second group, we need to be extra careful because one of the terms is negative. They both have a factor of m, but we want the inner parentheses to be n minus 1 to match our other parentheses. So we'll factor out a negative m to get negative m times n minus 1 for our second group. Great! Our parentheses match, so we can factor out n minus 1 and get 2m squared minus m times n minus 1. We're not quite done since we can pull out an m from our first set of parentheses. So we get m times 2m minus 1 times n minus 1. Great! As always, let's check our work by expanding the factors. When we multiply this back out, we get 2m squared n minus 2m squared minus mn plus m, which matches our original expression. So we factored correctly. Great work! Now you're ready to factor many different kinds of polynomial expressions.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.